Hello everybody, my name's Ken Riley and we have another exciting Copperland video for you today. Today is Turbine Builders Day. We have a Turbine Builders Club and this is the next video in that series. And the kind of turbines that we're looking at are what they call disc turbines. Tesla was one of the people that worked on disc turbines. He wasn't the first one, but he actually made commercial or industrial models. We took his designs and improved on those and made his turbine even better. So this kind of a turbine has discs. Here's an example. This is actually a pump spacing. It's a wide pump spacing, so it's a disc pump rotor. And you get to the turbine spacing is very narrow, about 1/32 of an inch. And the principle is that the adhesion of air molecules to discs actually creates a kind of a barrier. And as you inject air between the plates, the molecules that are on the disc actually help the moving air to adhere to the discs and transfer energy. So this is a little demonstration model, 4-inch. We'll show you how these turbines actually work, what the principle is. And remember, protect your ears, protect your eyes, and I'll fire this thing up. And Tesla actually used steam in most of his industrial models because that was the age of steam. We're using compressed air, but it's basically the same thing, although steam with the water vapor in it is more efficient than air. Air doesn't have much mass. Steam has more mass. So here we go. I'll inject air between the plates, and you can see on the end of the shaft, you'll see that rotate. Okay, that's enough of that. So that shows you the basic principle of the disc turbine. We've made big improvements on what we put between the plates to increase the efficiency of Tesla's disc turbine to about 30% more. We'll go into that later. So that's a little demonstration model. Now we have a few different turbines we've been working on for years, and I'll show you exactly what we're progressing into. This is the first industrial model that we build, and you can see it's got an internal reservoir right here. This one has an internal pump. We're using, these are little cheap pumps you get from like Harbor Freight. It's a fountain pump, and that's enough of a pump inside of here to move your oil up and into the bearings. We also have internal to this one, we have this is a stator from a typical automotive alternator that's built in. And we have down below all of our outputs for three-phase power from that stator. So everything is internal to this. We don't have external parts of it. With some of our other models, we use external oil reservoirs and pumps. There's a pump inside of this can. So we built that oil reservoir and pump inside of there. And then we have the inlets and outlets. So the oil's draining from the turbine down into this external sump and then pump back up into the bearings. You don't need a lot of oil flow for the bearings. These are high-speed bearings, so it's just a very slow drip method. This shows another stator, three-phase wiring, and you pull these out of alternators like you see up here. This is an alternator we've been working on, another one over there. Different experiments. So that's another steam or disc turbine we're working up. It'll use compressed air or steam. Some more parts for those. And after spending a couple decades working on disc turbines that are powered up from steam or compressed air, we went into another one of Tesla's designs, which was pulse detonation. That's what we have over here. This is a basic pulse detonation engine that we put together from, this is an old two-cylinder snowmobile engine. We gutted that, made up new bearings. It's a new bearing for that. We have an electrically driven primary and secondary stage for the air. And then inside of here these are axial fans. And you have a radial fan inside of here that powers up as you get the shaft to move. That compressed air comes up into this chamber. We have a valve in this chamber, gas injection here, detonation here, and then that detonated hot high velocity gas comes out to your discs out here. So that's your pulse detonation engine. We have this is actually an ignition controller, ignition and gas controller for that. Various shafts that we've worked on. And this is a shaft I made up. Everything started with just metal rod like that. And it was turned down on the lathe like that. That's without the threads. And we made the threads and everything right on our home machinery. You can do all this with inexpensive home machinery. You don't need an industrial shop. That entire shaft, which is another pulse detonation shaft, was made on simple equipment that we have right here in our shop. And we have various stages of the rotors. The rotors that we we build here have very powerful magnets attached to them on the outside. Those inexpensive but powerful magnets you get out of China. This is another turbine bearing shaft. That's what you put your magnetic rotor on. This is a valve body that goes into the pulse detonation system, and it looks like a complicated part, but we made that right here with a couple of simple shop tools. There's a drive motor to actually drive the pump, or not the pump, the valve unit. We have a bunch of different things that we're working on, including wind turbines, a new type of motor generator, electric motor generator, very advanced. So we have a lot of projects going on, and it's really too much for us, but we take it a little at a time and see what's really needed around the world to solve problems like global warming, the pollution problem. Pollution problem is the worst. That's why we're concentrating on automotive solutions in the turbine area. This engine right here, the pulse detonation turbine, will replace the piston engine and all other forms of turbine engines. This is the engine of the 21st century, and we're developing it here to then work with industrialists around the world to immediately solve the global pollution and warming problem. Well, that's it for now. That gives you a good idea of what we're doing in the Turbine Builders Club. We have a CD available. It's a virtual CD. It's an online CD. If you want to download, they're actually plans and they're CAD files for building up one of these steam turbines, steam or air-driven turbines, to learn the principles. And maybe if you learn the principles, you'll become a smart feller instead of a fart smeller, like Jeff says, and you may be able to build one of these pulse detonation engine. So until next time, we'll catch you later.